Hello, welcome to SQL Bits 2020, and welcome to this session on Azure Data Factory, Patterns and Best Practices. My name is Shirley. I'm a Group Product Manager on Azure Data Governance team, and it's my pleasure to bring you this session. Here are the topics we'll go over in this session. First, I will give a quick overview on Azure Data Factory in case you're new, just so we can get on the same page. I'll spend most of the session talking about common data integration patterns, best practices, and we'll conclude looking at recent enhancements and forward-looking roadmap. So why should you care about data integration and ADF in particular? Well, according to a recent Forbes magazine on the state of enterprise data integration, 80% of business leaders say that data integration is critical to their business. 67% rely heavily on data integration to support analytics and BI workloads. And about 2/3 of organizations have a preference for using cloud platform or hybrid data integration solutions. So Azure Data Factory is a hybrid data integration that aims to simplify building ETL workloads in the cloud. There are four main value propositions that ADF offers to our customers. The first one is ease of use. ADF provides a code-free authoring experience to allow data engineers and citizen data integrators to easily construct and operationalize ETL and ELT workflows. ADF is also fully integrated with other Azure data services, so building cloud analytics on Azure is easier than ever. ADF is super powerful. It comes with 90+ built-in connectors, maintenance-free, and it helps you to orchestrate and monitor at scale. Enterprise readiness is top of mind. ADF offers best-of-breed Azure native security, and it offers Git integration and full CI/CD. ADF is also cost-effective. It's offered as a fully managed service. It's serverless, which means the compute is provisioned just in time. It scales on demand. And as a user, you pay for what you use, not for how long it's reserved. I'm sure many of you have heard about Azure Synapse Analytics. We announced public preview of Azure Synapse Analytics at Build conference earlier this year. Simply put, Azure Synapse Analytics reduces the time to insight by offering a fully integrated data platform to build cloud analytics workloads. It achieves that by combining the SQL data warehouse capability with the big data Spark capability, and now the full set of data integration capabilities that you know and love from ADF is also fully integrated as part of Azure Synapse Analytics. That means you get a very consistent management, security, monitoring, and meta store experiences. So for the remaining of the talk, whenever I'm referring to ADF patterns and best practices, keep in mind that the same patterns, best practices also apply when it comes to doing data integration inside Synapse. So next, let's look at the core capabilities. At a very high level, ADF has these 5 core capabilities: ingest, control flow, data flow, scheduling, and monitoring. Let's take a brief look at each one of them. So the first one is ingestion. With the 90 built-in connectors, ADF enables you to easily acquire data in any shape, format, or volume, from relational data warehouses to big data stores to file-based stores, NoSQL stores, SaaS applications, and of course, from any of the Azure data services. Using ADF, you can ingest data from on-premise, from Azure, or from other cloud providers. Because ADF is serverless and super scalable, you can take full advantage of the ingress and egress capabilities of the data stores, as well as the underlying network bandwidth. In specific cases, we've seen customers achieve up to 5 GB per second throughput. That's really fast. Once you have ingested the data using ADF into Azure, now you're ready to perform rich transformation. With mapping data flow, you can construct and perform ETL and ELT processes very easily in an intuitive, code-free drag and drop environment. The mapping data flow UI will take the ETL logic that you compose and run them on a scale-out Spark execution environment. So this essentially frees you from having to learn and build Spark knowledge or Python or Scala coding skill sets. And the ETL logic becomes very resilient and easy to maintain. Using the rich control flow, including branching and looping construct, you can compose the ingestion and transformation logic into a very durable end-to-end pipeline. Once you're happy with the pipeline design, you can also operationalize the pipeline execution using a variety of trigger types, whether it's executing on demand, on a schedule, tumbling window trigger, or even event-based. And finally, your DevOps team can monitor the end-to-end execution of the pipeline through the single pane of glass monitoring experience. ADF is also fully integrated with Azure Monitor, so you have access to the rich diagnostic logs, metrics, and you can set up alerts based on custom thresholds. All right, so that's a very quick 5-minute whirlwind tour of what ADF is at a very high level. So now let's change gears and talk about the common data integration patterns that ADF customers are building. The first pattern I want to talk to you about is data lake and enterprise data warehouse migration. Oftentimes, customers do not start from scratch when they build cloud analytics workload in Azure. They oftentimes start with an existing data lake on AWS S3 or an on-prem Hadoop ecosystem. Alternatively, they might be starting from a data warehouse appliance like Oracle Exadata, Netezza, Teradata, or AWS Redshift. So their first step is migrate the existing lake and data warehouse, and also set up incremental pipelines to keep the data lake in sync. So here are 3 real-world customer examples. The first customer wanted to migrate 2 petabyte of data lake from S3 to Blob, and they were able to achieve that in less than 11 days, while achieving somewhere between 2 and 3 gigabytes per second load speeds. The second customer in the middle, instead of completing the migration and decommissioning their existing lake, they actually want to keep the data lake in Azure in sync with the source, which happens to be S3 in this case. And the other difference is, instead of moving the data over public internet, they want to accomplish the data transfer over a private peering point between AWS Direct Connect and Azure Virtual Network. Using ADF, they were able to achieve very effective link utilization over this 10 gigabit private link. Their initial load was 1 petabyte in size, and subsequently they have been doing 1 petabyte per month incremental load. The third example is a customer who migrated successfully a 25 terabyte on-prem Netezza instance to Azure Data Lake storage. They were able to accomplish the migration by using the nightly migration window and limiting the level of concurrent connections in order to cap the overhead that they impose on the database. So what does the service architecture look like underneath the hood that powers the performant and scalable copy activity? Let's start from the top left, where you as the user can configure the number of data integration units as well as the degree of copy parallelism. The number of data integration units effectively tells ADF how much compute horsepower to provision on demand at runtime. The bigger the DIU, the more compute horsepower is made available. And that much horsepower is used to execute the copy activity in a very scalable way. If you leave the DIU setting as auto, which is the default, ADF is smart enough to pick the appropriate setting in accordance to your workload and dataset characteristics. Both during and after the copy execution, you can review the rich monitoring statistics, including the number of DIUs used, what is the timing breakdown in different stages of the copy, and we also recommend a set of perf optimization suggestions. So what if you need to ingest a large amount of data at scale from a non-file source? For example, a relational database or data warehouse like Oracle, Teradata, or Netezza. ADF has added out-of-the-box optimizations such that you can use either the physical partition already defined on the table, or you can specify a custom dynamic range partition. And using this partition information, ADF will divide up the data set, for example, a single large table with hundreds of millions of rows, into multiple partitions and load all these partitions in parallel. Another very common question we get asked from customers is, what if I have a large number of table objects that I have to load across many different database instances or even SQL server instances? And what if the set of table objects is not only large, but also change over time so that it may need to be updated or expanded? So over here, our recommendation is that you can use what's called a metadata-driven pipeline design. On the top is a sample metadata table where I have defined different columns to specify, for example, the server name, database name, table schema, table name on the source. And likewise, you can have one or more columns that define the metadata on the destination. In addition, I also specify what's the column to use as the watermark column and a column to keep track of the watermark values. So on the bottom, based on this metadata configuration, you can define a 3-tier or 3-level of pipelines. The main pipeline simply iterate through, it would first do a lookup to retrieve the list of databases, and it will iterate through each database and call the second child pipeline. The child pipeline in the middle will iterate through all the table objects within that database and invoke the bottom pipeline. The bottom pipeline, the grandchild pipeline, is the one that does the heavy lifting. It will pick up the single table object, and it will do either a full load or an incremental load using the watermark approach. So in this way, by utilizing the parameterization for the link service, the data set, and at the pipeline level, we can very effectively have a templatized set of pipelines that is entirely driven by the metadata configuration in my relational database. Or you can store the config in a file. Either way would work. But the key point here is there's no hard-coded value, and the pipeline pattern is reusable across different environments. The second pattern I want to talk to you about is something called the code tree ETL. So using the copy activity, you can very effectively ingest data from the variety of data sources that ADF supports into the raw staging region in Azure, for example, ADLS Gen 2. And then from there, you can chain the copy activity with one or more mapping data flow activities to further refine the data and then curate the data, cook the data, process the data, and finally load that data into your data warehouse or data mart for BI reporting purposes. This approach is very composable and flexible because you can independently scale the compute for the different copy steps and for the mapping data flow. And you can fully leverage the scalable elastic compute horsepower in Azure to do big data processing. So here are some real-world customer examples who successfully used mapping data flow to achieve their business goals. In the first bucket here, for legacy ETL tool migration, we've worked with companies in the oil and gas industry to migrate 10 years worth of Informatica Power Center mapping over to ADF pipeline and data flow constructs. In another example, a customer in the hospitality industry successfully migrated large sets of IBM data stage ETL logic to the cloud using ADF data flows. In terms of analytical data warehousing ETL pattern, we have a lot of customers, existing SSIS customers, who have over the years lot of investment in building out SSIS packages. So within ADF, we not only provide you with the ability to lift and shift these SSIS packages and run them at scale in a fully managed manner in Azure, you also have the option to modernize these SSIS package logic over time using data flow and ADF pipeline. So here, with a customer in the property management business, we help them to rewrite the slowly changing dimension logic and reduce from 20 to down to 2 data flows. In the third use case, for big data analytics applications, we've worked with customers in the marketing and analytics vertical to migrate from Alteryx to ADF using data flow, and we are helping them to analyze tens of thousands of client ad results on a daily basis. So let's take a peek at the service architecture behind mapping data flow. Again, starting from the top left, using the drag and drop code-free UI designer, you can quickly and effectively design your ETL flows. And as you build out the data flow logic, the UI will convert that into data flow scripts. And at runtime, ADF spins up at scale Spark clusters on demand and execute those data flow scripts. Just like copy activity, with mapping data flow, you have access to rich, in-depth statistics in the monitoring view that detail out the time spent on each individual step of the transformation. And you also can look at evaluate the effectiveness of the partition. For example, look at the data skew between the partitions. So let me show you in my live Data Factory environment how you can configure Azure Data Integration runtime to effectively execute your mapping data flow. Here's a data factory that I have already created. And if you head over, let me discard my previous changes. If you head over to the Manage menu option and under Integration Runtimes, you can see the existing of data integration runtimes that you have already configured and look at their statistics. From here, you can also create new instances of integration runtime. Let's say I want to create one for running my mapping data flow. You would choose the type as Azure. After you enter the name description, down at the bottom, if you expand on data flow runtime, is where you can customize the different properties. So you have general purpose, compute optimized, and memory optimized as the compute type. You can also choose how many core count for your worker nodes and for your driver cores. You can choose a relatively smaller cluster size for your debug session, but if you want to operationalize, you can choose a bigger scale of the cluster. The time to live or TTL setting is especially helpful to reduce the cluster warm-up time. So let's say if you already have executed a mapping data flow activity and you're about to spin up a subsequent one. As long as the subsequent activity execution is within the TTL value, then you can cut down the warm startup time. So the startup time for the warmed up cluster would be around 1 to 2 minutes, as opposed to the usual 4 to 5 minutes for a cold startup. These values can also be dynamically set depending on the data set size or data volume. So you don't have to hard code these. And in fact, you can dynamically adjust these settings based on your workload. Back on the authoring, this is where you can define new data flows by going to data flow and create new data flow definition. But you don't have to always start from scratch. If you click on the plus sign, you'll see an option that allow you to create pipelines from template. Here's the template gallery where we have a ton of pre-authored, ready-to-go templates that you can take and deploy very easily. You can also further customize the pipelines that to better suit your specific needs and scenarios. So if I filter on data flow, you will see a bunch of pre-canned, ready-to-go templates that you can use. Let's pick the do pipeline as an example. So by clicking on this template and inputting the link service for the blob storage and click on use this template, that will take me to the pipeline design canvas with the mapping data flow already configured for me, ready to go. You can double click into that and see that in this particular example, I'm doing a dedupe of the employee data set by looking at, by doing a fuzzy matching on a set of, on the full name of the employee. So as long as the Sundex function is the same, then multiple rows are determined to be duplicates of each other. And I can decide, whether I want to remove the duplicates and only keep one of them, or only mark the rows as duplicates and decide how I want to treat them in a downstream logic. So using this template, you can, change to a different data set or swap out the fuzzy matching logic with an exact matching logic. And then also decide, how you want to handle the duplicates. But the basic pattern is laid out for you, so you don't have to, start from an empty canvas. In my deck, I have other patterns in addition to data deduping. For example, slow changing dimension, type 1, type 2, fuzzy lookup, and how to load star schema DW. All these patterns are available as templates in the template gallery that I just showed you. So in the interest of time, I'm going to skip over these slides, but the slide will be available to you after the session. So you can easily find the templates and go and explore and then further customize on top of these. Let's go back to our main flow of the presentation, and then let's talk about pattern number 3, which is a extraction loading and combined with code-based transformation. So ADF, in addition to built-in connectors and built-in ETL capability, it is also fully integrated, as we mentioned, with other analytics capabilities in Azure. So we've seen other customers who opt to use Azure Databricks notebook for data cooking and transformation using Python and Scala code. We've seen other customers use ADF to load data from on-prem, cloud, and SaaS data sources into Azure into a staging table in Synapse SQL pool. And then the further cooking and curation happens via store procedure executed through ADF orchestration. We have also plenty of customers running Hive and Pig against HD Insight, integrating with Azure Function. ADF also comes fully integrated with Azure Machine Learning. So you can operationalize batch scoring, or you can use ADF pipeline to retrain your model periodically using new sample data sets. And last but not least, if you have custom code that you want to integrate, ADF allows you to execute custom executables on bring your own Azure batch pools. So, all 3 patterns combined together gives you a really rich set of choices and allow you to compose very flexible ETL pipelines. All right, so now we're going to switch gears a little bit one more time. So just now we looked at the 3 main integration patterns, and now we're going to look at some of the best practices. And these best practices really cut across multiple patterns, multiple scenarios, so they're commonly applicable. So customers who have multiple projects coming up within their organization, and they also need to model and take their project from dev to test to production. And a common question that we get asked a lot is how to express this tenancy model. And our recommendation here is really to have a separate factory for each project and each environment. So the dev factory, we recommend that you associate it with a Git repository that allow you to have the CI/CD, as part of your development lifecycle. the changes are taken from the dev environment to test to prod, whether it's incomplete or in incremental mode, using the Azure DevOps pipeline or ARM template export-import mechanism. When it comes to the prod environment, often there is a need for separation of duty. So there's the role of data engineering team who are responsible for deploying the pipelines, and hence they need access to read and write all the factory artifacts. Then there is a separate SRE team, the site reliability engineering team, who are really held responsible for monitoring, rerunning, and debugging these pipelines. So they need ability to execute and also to view the logs. And finally, there is the role of the infrastructure team. The infra team is responsible for setting up the actual Azure resources. For example, Azure Key Vault. They also define and configure the authentication model. For example, establishing the managed identity-based access from the Azure Data Factory to AKV. They're also responsible for setting up the self-hosted integration runtime, for example, to access on-prem data assets. So in ADF, if you find a need to express this level of separation of duty, our recommendation is to use custom roles so that you can define the granular RBAC models to define different level of operation on different sets of resources within the factory. I want to spend some time talking about factory metadata and data security because security is clearly top of mind for many enterprise organizations. First one is how to encrypt factory metadata and logs. So recently we added this capability to be able to encrypt, in fact, double encrypt the factory metadata and logs using both the system key that is managed by ADF and a customer managed key, CMK. ADF supports TLS version 1.2. So as long as the data store supports HTTPS or TLS 1.2, then the data transfer is happening over secure channels like HTTPS and TLS. In terms of data encryption at rest, even though ADF doesn't additionally encrypt data at the application level, our suggestion is that you take advantage or leverage the data store built-in encryption mechanism. For example, transparent data encryption for Synapse SQL Pool and Azure SQL Database, or SSE for Azure Storage. Here's some additional advice on how you can design secure and credential-less pipelines. So first one on authentication. Our suggestion is for Azure services that support AAD-based authentication, you should use managed identity or service principal for authentication. For non-Azure services, ADF supports whatever the built-in, most common built-in auth options, including basic auth, key-based authentication, Windows auth, and so on. So if it is a managed identity, then there isn't really any credentials being stored or being passed around. But if you're using service principal or any of the other non-Azure based authentication mechanisms, then our suggestion when it comes to credential management is to store these credentials in Azure Key Vault. So ADF can authenticate to AKV using managed identity. That's the bootstrap step. And then from there, it can retrieve the secrets, the credentials that are stored in the Key Vault. So this is a very secure chain of steps, right, when it comes to credential storage, management, and retrieval. You do have the option of alternatively storing the credential inline in link service. When you do that, you're really asking ADF to manage and encrypt these credentials for you. So the cloud credentials behind the scenes, they're encrypted using ADF managed certificates. And the on-prem credentials are encrypted using Windows DP API and stored locally on the self-hosted integration runtime. These on-prem creds, even in encrypted form, they never flow to the cloud. So for high value and highly valuable Azure resources, customers have a need to lock down these Azure resources from a networking security perspective. The recommendation is to use private endpoints, which essentially establish a secure channel from within your own virtual network to these highly valuable Azure resources. I'm very excited to share with you that recently ADF has released the support for private endpoints through an ADF managed VNet. This capability is currently in public preview, so I really encourage all of you to try it out, evaluate it, and let us know what you think. The way it works on a high level, if you look at the network diagram on the right, is that once you enable managed VNet in ADF, ADF will create a managed virtual network on your behalf. And every time you establish a connection by creating a link service to Azure Storage or Azure SQL DW, any service that supports PE, what happens is that ADF will additionally create a private endpoint from within the managed VNet to these secured Azure resources. So these Azure resources no longer have any way of getting to them. They're completely blocked from public internet-based access, and they're only accessible through the ADF managed PEs inside the managed VNet. At runtime, the Azure IR, the integration runtime compute is provisioned from within the compounds, the boundary of the ADF managed VNet, so that the entire extraction, transformation, and loading logic, the integration logic happens from within the VNet, and your data stores are totally protected. All right, so time for a demo. I want to use this demo to kind of put everything together that we have talked about so far in this session. And the example you'll see is how to use ADF to ingest and curate a COVID-19 data set. So before I show you the demo, I want to take a step back and talk about the Microsoft Open Data Set. So over here on the azure.microsoft.com website, by going to Open Datasets, you'll be able to see a set of curated datasets that are openly and readily accessible to all of you. If you type the keyword COVID, you'll find a dataset called COVID-19 Data Lake, which contains 4 different datasets, from Bean to COVID Tracking Project to the European Center for Disease Prevention and Control and Oxford COVID-19 Government Response Tracker. So these datasets are available, are maintained and made available from Microsoft to assist the efforts that are ongoing by the different governments and different organizations to combat the global pandemic that's impacting so many of us. So using these data sets, you can further augment and combine with data sets from partners, from your own organization to decide how to, to decide on social distancing policies or decide when would be a good time to reopen and look at, some of the recent trends on testing and hospitalization, etc. So behind the scenes, these all 4 data sets are actually ingested, prepped, and curated using ADF as the data integration engine under the hood. And by double clicking into one of these data sets, you have the URLs where you can get to these data sets in different formats, as well as there's a GitHub setup where you can get access to how the pipelines are constructed. You can even download the templates and play with it on your own and use it as a baseline to further augment your COVID-19 analysis. So I have done that in one of my factory instance here. If I pop over to the authoring panel, you'll see that there's a pipeline called COVID tracking. And over here is my pipeline definition. I have a copy activity that ingests data from a GitHub location using HTTP connector and land that data into my blob storage as my data lake. And I'm customizing every time when I load it, I'm loading to a different folder that's in the format of year, month, day. So in this way, I can keep a complete history of the daily data sets that I'm ingesting. And over here on this copy activity, I'm loading the same data set, but instead I'm writing to a folder called latest. So, I have the history as well as the most recent day worth of data set to work with. Chained with these 2 copy activities is a mapping data flow activity. So in here, I'm augmenting and enriching the data set with a metadata column called load time that tells me what time of what is the year, month, day when I loaded this data set, and also the ISO code. And further down in my processing step, I further reformat the columns, drop extra columns, do some more munging, and make these data sets available in the form of Parquet, JSON lines, and CSV. Back on my pipeline design canvas, I further convert using the copy activity, convert the JSON lines to JSON format. So all of these is done in a operationalized manner and is what's running behind the scenes to produce the open data sets. So because the COVID-19 data can contain hospitalization patient data, and I may also want to further augment with my own enterprise data, I've decided to use a secure and locked down data lake for all of my ETL operations. So over here, you can see that this data set is pointing to a storage location called Shuang Storage East US PE. And I'm connecting to this data lake using the manage VNet functionality. And further, I'm connecting to the data lake using manage identity. So I make sure that I do not pass any security around, and the entire authentication process is as secure as it can be. Let me pop over to the storage side. As you can see here under firewalls and virtual network, I have locked down the network access to the storage to select network only. And in fact, I've limited to this particular virtual network, which means there's no firewall or IP whitelisting. There's not even allow trusted Microsoft service. The only access that's allowed is through this private endpoint, which was established from my COVID-19 demo data factory to this storage. Over here on the monitoring view, here's an execution run that I did a couple of days ago. And you can double click into that and see the run statistics of individual steps inside the pipeline. By clicking on the eyeglass icon, you will see further details on the copy step, as well as on the data flow execution step. All the statistics can allow you to determine if your configuration setting is set appropriately and further optimize performance characteristics. All right, so we continue to learn from all the customer engagements about the common patterns, and we also use the customer feedback and learnings to drive the set of motivation or to motivate the set of product enhancements that we continues to make to ADF. So I know this is a busy slide. It's available to you, so you can go through in detail. On the left column are all the new enhancements that have been delivered in the first half of this calendar year. And on the right are the set of enhancements that we plan to do and we're working on as hard as we can in the second half of the calendar year, CY20. But if I were to step back and summarize, there are three main investment pillars in terms of ADF roadmap. The first is around enterprise readiness. So we want to take managed VNet to GA. We want to further enhance our cloud scalability and developer productivity. We're also adding extensibility to ADF, which means you can bring custom plugins, whether it's connectivity or the transformation logic. We want to further flesh out the end-to-end analytics capabilities in Synapse Analytics by adding code-free workflow and data flow. So for example, wrangling data flow will be added. It's right now available in standalone ADF, and it will also be available in Azure Synapse Analytics. We will take common data model support from the current public preview to GA so that it will become even easier for you to ingest and work with the common data model data sets. We will, of course, continue to enhance our SSIS integration capabilities so that it will become easier than ever to lift and shift your existing SSIS workloads. And we'll continue to enhance our built-in connectivity and built-in data transformation capabilities. All of this combined together will allow you to easily take legacy ETL workloads to Azure and convert them to ADF pipelines. We have a bunch of learning resources as part of ADF documentation, from tutorials, how-to guides, end-to-end labs, and white papers based on the many customer examples and engagements that I've mentioned, and many more. We also love to hear from you. Please, reach out to us through MSDN forums, Stack Overflow, ask your question, and we'll try our best to get back to you with answers. And of course, you can stay in touch on all the latest and greatest ADF enhancements by following us on Twitter. All right, that's the end of the session. Thank you for watching. I hope you have fun building workloads using Azure Data Factory, and we love to hear from you.